Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to discuss about refraction of light. We know light travels with different speeds in different media. The plural of medium is media. So the speed of light is different in different media. Speed of light is maximum in vacuum. It is 3 into 10 to the power 8 meter per second. Let us assume this is our medium 1 and this is our medium 2. When light traveling in one transparent medium strikes the boundary of another medium obliquely, then a part of this light ray is then a part of this light ray enters the second medium. Light ray is coming, this is our incoming ray, and this is the boundary between two different transparent media. So light ray is coming and striking the boundary obliquely. Then a part of this light ray enters the second medium and another part gets reflected back into the same medium. So this is the reflected part, and another part is of the incoming ray enters the second medium. So when it enters the second medium, it changes its direction. Let us assume that medium 1 is denser. Medium 1 is optically denser, and medium 2 is optically rarer. So if we draw a perpendicular at the point of incidence, this is our normal at the point of incidence. A part of this ray is reflected and the other part is refracted, but it changes its direction. ठीक है? The direction of incident ray is this, but when it changes medium, for example, it is entering a optically rarer medium, then the ray bends away from the normal. The refracted ray bends away from the normal. So the energy of the incident ray, this is our incident ray. So the energy of the incident ray is divided into three parts. One part is reflected, the other part is refracted, and the third part is absorbed. Okay, so three things happen: reflection, refraction, and reflection, refraction, and absorption. So total energy of the incident ray is divided into three parts: reflection, refraction, and absorption. So we can see that when a light ray traveling in a transparent medium strikes the boundary of another medium, it changes its direction. It moves away from the normal. This phenomenon is called refraction. Now again we can say, if a light ray this is our medium 1, this is our medium 2. A light ray passing through a transparent medium obliquely strikes the boundary between obliquely strikes the boundary of another medium. So this is our medium 1, this is our medium 2. In this case, let us consider the opposite case. The light ray is coming from an optically rarer medium, and it is entering into a into an optically denser medium. This is exactly opposite to the first case. So if we draw a normal at the point of incidence, this is our point of incidence, this is our normal, this is our incident ray. So we can say, when the incoming ray strikes the boundary between two different media obliquely, a part of it is reflected back into the first medium. So one part of this ray is reflected back into the first medium, and the other part of this ray enter the second medium. So when the incoming ray enters the second medium, when it enters from an optically rarer to a denser medium, the ray bends towards the normal. This is the actual path of the ray, but it bends towards the normal. So when a ray of light passing through a transparent medium strikes the boundary between two different transparent media, one part of the total energy of the incident ray is reflected back to the first medium, and the other part of the total energy enter the second medium as refracted ray, and the third part of the total energy gets absorbed at the boundary. So we can see from the diagram that when light passes from optically rarer to optically denser medium, it bends towards the normal. So we can see a change of direction. So this change of direction of light when it passes from one medium to another medium is called refraction. Now we can write the definition of refraction. Okay, so the definition is when light traveling in one transparent medium obliquely strikes the boundary of another transparent medium, a part of light passes into the second medium and it changes its direction. This phenomenon is called refraction of light. This phenomenon is called refraction of light. Okay, that means refraction means change of path of light. When traveling from one medium to the other. Okay, so in short, we can say change of path of light when traveling from one medium to the other. This is called refraction. Okay, so the definition of refraction is so we can define refraction as when light traveling in one transparent medium obliquely strikes the boundary of another transparent medium, a part of light passes into the second medium and it changes its direction. This phenomenon is called refraction of light. Refraction means change of path of light when traveling from one medium to the other. This is our refracted ray. And this is our incident ray. This is our reflected ray. And this is our refracted ray. Now we can say that this angle is called, that means the angle between the normal at the point of incidence and the incident ray. This angle is called angle of incidence. And the angle between the normal and the refracted ray, this angle is called angle of refraction. Okay, same for this diagram. Now one more thing, the angle between the refracted ray and the path that the incident ray should be following. Okay, this is the path. I have drawn it by dotted line. The path that the incident ray should be following is this, which is shown by the dotted line, and this is the actual path. Okay, so the angle between these two direction, the angle between these two directions is called angle of deviation, which is denoted by delta. Okay, for the second diagram we can see that this is the delta, this is the path that the incident ray should be following, and this is the refracted ray, this is the actual path. So the angle between these two paths is called angle of deviation. Okay, so delta represents angle of deviation. Now we are going to discuss, this is our medium 1, this is our medium 2. If the light ray strikes the boundary between these two media normally, then without any deviation the light ray will enter the second medium. So this is 90 degree. Okay, this is the boundary. So when the light ray, instead of striking the boundary obliquely, if it strikes perpendicularly, then it suffers no deviation. So the light ray enters the second medium without suffering any deviation. In this case we can see this is our point of incidence and this is our normal. Okay, this is our normal. So we can see that the normal and the incident ray lie on the same line, The normal at the point of incidence and the incident ray and the refracted ray lie on the same line. That means we can say the angle of incidence in this case is 0 degree. Okay, and the angle of refraction is also 0 degree. So it suffers no deviation. The light ray incident normally on the surface separating two media passes into the second medium without deviation. And we should remember that the intensity, that means the energy of the refracted ray is always less than the incident ray, because the incident ray, the energy contained in the incident ray gets divided into three parts. So these are the points we should remember. Now let us discuss about laws of refraction. The laws of refraction. The first law says the incident ray the refracted ray and the normal at the point of incidence lie on the same plane. Okay, that means incident ray, refracted ray, and the normal cannot be in two different planes. Okay, they will always lie on the same plane. Number two, if for a fixed pair of media, we cannot change any one of them. Okay, these two media are fixed for a fixed pair of media, and for a fixed wavelength of light, the ratio of sine of angle of incidence, the ratio of sine of angle of incidence to sine of angle of refraction is a constant. Okay, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That means sine of angle I by sine of angle R is a constant. This constant is represented by mu2 1. This letter is called mu. Okay, mu2 1, which means the refractive index. Okay, the mu is also called the refractive index of second medium with respect to, I am writing it in short, with respect to first medium. Refractive index of second medium with respect to first medium. Okay, this is our refractive index. Now, if the first medium is vacuum. Okay, if the we can say mu m any medium, okay, with respect to vacuum. Okay, so the refractive index of any medium with respect to vacuum is called absolute refractive index. Absolute RI, absolute refractive index of the medium. Refractive index has no unit. Okay, refractive index has no unit. This is a ratio of two similar quantities. I hope you have understood all the concepts. That's all for today. Tomorrow we shall come with another video. In our next physics class, we are going to learn different representation of refractive index and factors that can affect the refractive index of a medium, and we are going to take some numericals related to it. Thank you, friends.